In this video, we will look at the second half of the Proctabulate notes. In this example, we will try to produce a table which is similar to that produced by the default Proc freak. The default output from the freak procedure displays counts, total percentage, row, and column percentages for a two-way frequency. We will look at SAS next. Here in SAS, I have the Proctabulate SAS code pulled up, as well as the results viewer from last time and the log. We can produce a similar table using the tabulate procedure by specifying statistic keywords N, PCTN, and PCTN with variables defined as denominators using angle brackets. And we can see that looking here. Count and total percentage are what we would expect. The row percentages represent percent of gender within the blood pressure status. So the PCTN is specified for variable sex. Since we added the universal class variable all for sex, we need to also add it for keyword PCTN. Similarly, column percentage are for percent blood pressure status within gender. So the PCTN is specified for variable BP_status. Running the code, we get the following. The output table from the tabulate procedure displays the same information that we would get from Proc freak. Let's also run the Proc freak so we can compare. For the all patients column, we can only focus on number of patients and total percentage because row percent would always be 100% and column percent would always be the same as the total percent. Looking at the gender for male and female, notice for each of the blood pressures we have number of patients, total percent, row percent, and column percent. Again, coming down to Proc freak, notice that we have the same thing. For male and female, for each of the blood pressure statuses, we have frequency, percent, row percent, and column percent. So the labels for the values are located here, and then the values are located within each of the cells. Looking at the Proctabulate, reading these is a little bit easier because the labels are located next to each of the cells. We can also see those results here on the PowerPoint slide. As I mentioned earlier, the highest dimension of the table is page. Therefore, only 2 commas can be used in the table statement. By statement can be used to generate similar separated output tables. By statement creates a separate table for each by group. Next, we will look at the SAS code. We know that to use the by statement, we need to sort the data set by the by variable first. And so we can see that right here. Running the code. Remember that when you run the proc sort, nothing will appear in the results viewer, but you may want to check the log to make sure everything ran correctly. Next, we'll run the Proctabulate code. Here we get 6 tables from the procedure. 3 for each gender from different blood pressure status. Due to the page limitation, the PowerPoint will only display the results for female. Male has 3 similar tables that we can see here. The 3 female tables are listed above. In each table, counts by living status by smoking status are shown within the gender and blood pressure status combined category. So for example, looking at the first female table, notice here we have the different smoking statuses for blood pressure normal as well as the status. Whereas the next table looks at female with blood pressure status optimal, also having the smoking statuses as well as the overall status. So if you want to look at more than 3 categorical variables, and you would like to look at the counts or percentages from all possible combinations of these variables, the by statement can be used together with commas to get tables for the combinations. Again, here in the PowerPoint, we can see the 3 different tables for female compared together. Again, the overall structure of each of the 3 tables is the same. What changes between the 3 tables is the different blood pressure statuses, and then within each of those blood pressure statuses, we can see smoking status and overall status. We've learned how to change the variable label using the variable equals text option. Other than add a label for each keyword separately, key label statement can be used to assign the label for those keywords. It can be helpful to define the same label for the same keyword shown more than once in a table statement. However, if you specify a different label in the table statement, the output table will display the label from the table statement rather than the one from the key label statement. As we can see in this example, we specify a label total for all, a label average for mean, and a label SD for standard deviation. Those can be seen right here. However, we specify a label mean age for the keyword mean for variable age at start. We can see from the output table, first running the code, total is displayed for both gender. Average and SD are displayed for the keywords mean and standard deviation. However, for average age, since we specify the mean age instead of average, so the mean age is displayed for the label for age. And we can see that right here. We have the mean average for age, whereas here for height and weight, we have average. And again, looking at the code, this is because the key label for mean is average, but for the age variable, notice that right here we specify mean age, and so this overrides the key label. And we can see that here in the PowerPoint as well. Label can also help to eliminate rows in the output table. Here we'll look at a couple different examples. Here in the SAS code, notice first that we have a couple different examples. We have example 1A, 1B, and then we also have 2A, 2B, and then we have a 3A and a 3B that we'll look at momentarily. In example 1, by specifying the 2 quotations with a space between them for sex, and the 2 quotations without the space for N, we remove the first and third row from example 1. And we get a shorter table compared to example 1B. So let's run the 2 and see what it looks like. So notice, looking at example 1B, we do not have the N labels, but for example 1A, we do have the N labels. So notice that the space between the quotations doesn't matter, but what does matter is that we have specified this for both sex and for N, removing those rows. Similarly, for example 2B doesn't show variable name and statistic keyword either, as we could see in example 2A. And so again, running example 2A and 2B, Here we can see that we have further removed some of those rows with the labels. Next, we'll look at an example where eliminating a row makes a little more sense than it does in these examples. So again, here in the PowerPoint, we have the comparison of the results, for example, 1A through 2B, where we can see we've removed some of those rows that contain labels. Next, we're going to look at another example. Here we have the code for example 3A and 3B. Without eliminating rows for variable names and keyword in, Table 3A displays a row with in as labels for each column and an empty row for variable names. Table example 3B eliminates those two rows by adding label with quotations to the variable names in the keyword in. So let's run both of these and compare. We get a shorter table, but with all the information that we need. A title can be added to state the statistics in the table are counts. And so again, comparing these two, see that the extra information here is removed. Again, we can see that comparison in the PowerPoint slides. We can also change the order of the class values displayed in the table by using the examples seen here. The default order for a class variable is unformatted. It's based on the value of the variable. The values displayed in the table will be ordered from the smallest to larger for numeric variables or alphabetically for character variables. If you would like to modify the order of the class variables, customized format and different version of the variables are two options. For example, we may want smoker based on how many cigarettes they smoked. By default, the table won't be sorted by the order we wanted based on the variable values. So we try to modify this in two ways. In the first example, we will first create a format for smoking status by adding a number in front of the values. Then we use the order equals formatted option in the class statement. The output table will be sorted by the formatted values. However, the formatted values have unnecessary information in them like the numbers 1 to 5, because we have to use those numbers to create an order for the formatted value. So let's look at the first example. The first example, we'll use this code right here. Notice we first use a proc format statement. Looking at the proc format statement, here's where we can see that we've added the numbers in front of the labels. And we've done this so that 1 is the non-smokers, 2 is light, 3 moderate, 4 heavy, and 5 very heavy smoker. So remember, when you run a proc format statement, we won't see any output in the results, but we do always want to check our log. Next, we run the Proctabulate. Here, once we run Proctabulate, we get the table, but notice here are the extra values that we don't actually want, but were just used for the sorting. In the second example, we will first create a new numeric variable called smoking_in and assign the values based on the order we want. So we will assign 1 to non-smoker, 5 to very heavy smoker, and then create a format for the numeric values. So let's do that first. Here is where we create the new variable. Notice the new variable we're creating is smoking_in. We're going to use if-else statements. So for example, if smoking status is equal to heavy, then we would like smoking in to be equal to 4. So running. Again, notice when we run the data statement, we won't see anything in the results, but we do want to check the log. Next, using a proc format, what we'll do is we will reformat so that our numeric values have the labels that we want. Again, this will not appear in the results viewer, but we will want to check in the log. Finally, we're going to use the numeric variable with format to create the table. but we don't apply the formatted order to the table. The table is ordered by the values of variable smoking_n from 1 to 5. Personally, I prefer the second way to order the table, although the second example takes extra data steps. However, you have more flexibility to modify the formatted values. So running the code, notice that we get the table that we want, and if we look at our smoking status labels, they don't have those extra numbers in the front. They don't have to be created in a way that you want your data to be sorted, since they don't have the impact on table order. And again, we can see that example here looking at the PowerPoint slide. Do remember, for the second way, you do want to remove the order equals formatted. If we would like to look at age by smoking status, one way is to use smoking status as the row variable and display mean age as the column. Recall the smoke format that we made earlier here. We can apply this format to the variable, and we will get the non-indented class variable values table. And we can do that by running this piece of code right here, which has the non-indented class variable values. So notice I am going to skip over this proc format smoke A. I'll talk about it in just a moment. And notice here is where we're calling the smoke format. So running this table. This table looks nice, but it would be better or clearer if the variable values were indented. So looking here to the left under smoking status, since each of these are a smoking status, it would look nicer if each of these were also indented, since they're really under smoking status. This will create a difference between the variable itself and its values in the table. So again, the variable itself is smoking status, but the values are those that fall underneath. So to do this, we can use a format with spaces in front of the values to create the indent. However, simply adding spaces, we will see, is not enough. So for example, here we have proc format with value smoke A. Notice that we have this piece of code right here. Ignore this for just a moment. We're going to come back to this. But notice in front of very heavy, we've placed 6 spaces. So let's run this formatting. And then we'll run an indented table. So looking at our new table that was created, notice that each of the values that had this piece of code right here looks exactly like we want it. But if we were just to try to put spaces to create the indent, it doesn't, give the result that we want. And we can see that that value right here is not indented. To fix this, we use a special character and define it in the ODS escape character statement. The escape character statement is used to define a representative character to be used in output strings. We'll learn more about it in future lectures. Here, we're just going to adapt it as we use. We would like to assign something rarely used to the escape character. With the special character assigned, we apply it to the format and specify that we would like 6 spaces before the values. And so notice that's really what we're doing right here. So up here we have the ODS escape character, this value right here, and then we're really placing after it what we want. So notice if we copy this and paste it next to very heavy, rerun our format, and now rerun our table, we have what we want. Looking back at our PowerPoint slides, we can see exactly this. Here in the red rectangles, we have what we need to change to actually have the addition that we want. And in the blue circles, we can see that just adding the spaces did not produce the results that we wanted. In summary, Proctabulate is a really useful procedure that computes many statistics. You can fit many statistics from multiple variables in the same table and display them the way as you wanted. There are many statements and options that you can use to customize the table and to make it appealing to your audiences. There are other options and statements we didn't cover in the lecture. For example, like some other procedures, to get an output dataset from the procedure, you can simply add out equals dataset name in the Proctabulate statement. You can use the link located here in the slides to learn more about this procedure.